more writing equations from tables. We're looking at standard 6.4 today. I can write equations of exponential functions from a table. So we're reviewing our basic form for exponential functions. Y equals b to the x plus k. So write down what those values represent. What does your b represent? What does your k represent? So we recall that k is the floor. It tells us where the bottom of our graph is going to be right here. That is also called an asymptote, and that floor is found at y equals k. Our b value is our multiplier, and we can also think of that as a divider, because if we have a graph that's going downhill, you're dividing as you go through, but we've been talking about it as a multiplier. So from last unit, we were given a graph and we were supposed to write equations. So we're going to do that right now. The first thing we always did would be to mark and think about where our k value is. So we have this horizontal line here at y equals 4. That tells us that our k is equal to 4. So we would have an equation that's y equals something to the x power. That part stays constant. And then our k value is 4, so we have plus 4 in our equation. Now we're looking at our b value, and so I have to find my multiplier. So this is 1 right here. From here to here is 3 from our floor. And so to get from 1 to 3, what multiplier am I using? 1 times 3 would give me 3, and let's check to see if that holds here. So if I look at the length of the distance between the floor and this point, this is 9 units. And 3 times 3 gives us 9. So that multiplier works for both of those. I'm going uphill, which tells us that my b value is greater than 1. So the fact that I'm seeing my b value as 3 makes sense for that. So y equals 3 to the x plus 4. Now let's take that knowledge that we have about writing equations from a graph to writing equations from a table. So there will be similar steps to how we've done this before. First, you're going to find your multiplier from the table, and we'll talk about how to do that. That's going to be looking at our change in y again, and then looking at what the multiplier is between those values, and then finding the floor of the exponential. So what value are we getting really close to in our table? And then using our b and k values to write the equation. So let's start by finding the change in x and the change in y. So when I'm looking here, I can see that for each one of these, we are increasing by 1, which is what you would expect for an exponential function. I'm not seeing any clear multiplying pattern with numbers like 5, 7, and 13. And I focus on the integer values because it's harder to see, obviously, with the decimals that we have here. So when I do my first differences, I'm going to start down here first. And so from 5 to 7, we are increasing by 2. 5 plus 2 gives me 7, and then 7 plus 6 gives me 2. And because I know I'm looking for a multiplier, there is a nice multiplier there, but let's go back a little bit to see. And so we're going to look at what the difference is, and you can pull out a calculator to do that. So I can subtract 5 minus 4.33, and I get 0.67. Some of you might recognize that as 2/3, so 4.3 repeating. And so when I'm looking at trying to find out what my multiplier is, you can get your multiplier by doing some division. So we're wondering, what would I multiply by to get from 2 to 6? And 2 times 3 gives me 6. But if that wasn't easy to find, I could take 6 and divide it by the difference right above it. So 6 divided by 2 gives me 3. I could take 2 and divide that by 0.67. Now that's an approximation, so we're not going to get an exact number, but it should come out pretty close to 3. And you can see here that it's 2.98. So this confirms for me that the multiplier that we're looking for in this table is 3. So that's going to be our B value. So right here, I'm putting a reminder. What is the multiplier for our change in y? So our change in y was right here. We're focusing more on our integer values because that makes it more clear to see that 2 times 3 is 6. We got this 0.67. If we had been using fractions, we could see that this is that's 4 1/3, and that difference is 2/3. And 2/3 times 3 also gives us 2 to confirm. And we could confirm it up with these decimals, but that is unnecessary. The next step is to find the floor of our exponential function. And that is evident with these values right here. You can see that these values all have 4 point something, and they're all getting smaller and smaller. So our floor is approaching 4. So because you can see those values are approaching 4, I know that my K value is 4. So remember, this finding our floor has to do with our K value. Finding our multiplier has to do with our B value. That's what these values are going to be, and now we're going to put them into our equation. So I always start by rewriting my general form right here so I can more easily line up our values. So we have y equals our B value, our multiplier is 3 raised to the x power plus our K value, which is 4. And of course, this table right here represents the ordered pairs that we have shown on this graph. And so we can see our floor at K, and we can see that we matched our equation there. If you're given a table, you don't have to graph it. You can use these steps in order to get the equation.